All right. Good morning, everyone. Hope you guys had a nice weekend. So we're doing this last day of review for your AP exam tomorrow. What I want to start off with is just kind of going through what I have added to the website under today's date. I have a list of items that you may use to review. But I also included a number of different things, and just depending on what you want to focus on as you study this afternoon and this evening. So if you scroll all the way down to today's date, May 3rd. Okay, and there are 9 items that I listed here on my website, but I organized them by priority. So meaning that if there's only one thing you have time to do today, then let it be the first thing, which is 2019 AP FRQ, just to understand that it covers a lot of different topics, and you at least are able to get that review in before tomorrow. But then I also included other items for you to review if you have time. Multiple choice, free response, miscellaneous worksheets. So I'm going to go through these, and then you can just use them accordingly depending on how you want to study or what area you want to focus on. So first is the 2019 FRQ. So last year, 2020, was kind of a different year in the sense that the AP exam was adjusted to be just 40 minutes, but this year they're going back to a full exam format. So 2019 is the most recent one, and so we're going to work through that today. But I think in class we may only be able to get through number 1 and 2. The other ones, 3 through 6, you can work on your own. There's a key here. But I'm also going to be available this afternoon from 4 to 6 to go over the rest of the FRQs. And but I'll record it. If you can't make it, you can always check back on that link. Yeah. So these FRQs, the thing I like about this 2019 FRQ is that I think the topics are very it covers a lot, right? Or it covers the majority of the topics that you could expect on the AP exam. So I think it's good for us to go through them in class as well as a help session. And if there's only one thing you have time to do for today, then hopefully you can spend that time doing as much of the FRQ as possible. So we're going to start off with the antiderivative word problem. Typically, these show up. They've been showing up in recent years as either a number 1 or number 2 under calculator portion. So we'll definitely get a chance to go through that. Particle motion and Riemann sums, they don't always go together, but it seems like they'd like to put these 2 topics together because they're able to test students on particle motion knowledge as well as Riemann sums, reading from table. So we'll see both kind of being played out through number 2. So those account for the calculator questions. Now, just understand that they may mix things up. They may put a calculator question they wouldn't expect, like maybe they'll put an area volume under a calculator. So we really can't depend on, this order being the same as the exam that you're going to see tomorrow. But at least the topics are pretty consistent. So expected derivative graph on the AP exam, and we're going to go through that in this 2019 FRQ. Differential equations. Differential equations tend to be standalone with slope fields, but in this FRQ, they put differential equations with related rates. So I think that's what I've been seeing recently, where related rates is not a standalone FRQ. They tend to insert related rates into one of the FRQs as a part C or a part D. So, we're going to see that for number 4. Number 5, area volume involving disk, washer, cross section. So we can expect that we expect to see that for number 5. And then functions, miscellaneous theorems. These are problems, these are FRQs where it's just a collection of random assortment of concepts. So sometimes they may give you a table of values, but they may be asking questions that could range from applying product rule, equation of tangent line, quotient rule, chain rule, L'Hopital's, various theorems, derivative inverse at a point. So they can just a hodgepodge of just random topics just inserted into this problem. So we're going to see that an example of that in number 6 here. Okay. So that's priority number 1. If you only have time to do one thing today, hopefully you can have time to do this one here. Summary sheet. So these this summary sheet here, this is the one that you've been seeing attached to the back of your multiple choice pretest. So obviously you won't get to use this on your AP exam tomorrow, but I encourage you guys to read through this, look through this, see if you can commit a lot of these concepts to memory, because I put together what I feel is the most likely to show up on the AP exam. So I encourage you guys to read through it, study it, and commit as much of it to memory as you can. Third, derivative and integral rules formula sheets. So I included all the derivative rules and integral rules. I grouped them based off of patterns. So the first 2 pages have the rules all filled out. The last 2 pages are blank. If you want to use it to as practice. And I also created a video where I go through each rule, each grouping, and show the patterns to help you memorize those rules easier. So check that out if you feel like you want to spend some time memorizing some of these more obscure rules. Okay, and then next, okay, if you can get through all that, and if you still have more time, I encourage you guys to look through some of the past FRQs. So if you click on this link here, this is the College Board released FRQs from 2000 to 2018. We've worked through 2017, 2018, and then we're going to work through 2019. But if you click on this link here, this will take you to AP Central page. And these are past exam questions. So let's say you want to look at 2016. So if you click on 2016, go to scoring guidelines. This is the only link you have to worry about. If you click on scoring guidelines, it'll show you the problem at the top and the full solution. So I'm not really expecting you to work through these problems. I think you've done enough. But I think what's something that is good is just read through the problem. Read through the problem and see if you can formulate, what category is it? Can you visualize what steps you would take to approach these problems? And then you can confirm that by looking at the solution below. And the more that you read, the more you're going to see, wait, all these kind of fall into a certain pattern. There's a certain way that they ask questions. And, the more types of problems you can kind of process tonight, chances are tomorrow you're going to feel like, oh, wow, I've seen this already. I kind of know how to approach it. So the more familiar you are with the different FRQs, especially in the past 10 years, I think there's only so many ways that they can ask a question or test you on the concept or reference a concept. So if you have time, I encourage you guys to look through and just scroll through past FRQs and just read the problems. Next up, I also have a list, a collection of FRQs, but this is the FRQ free response notebook. So these are a little bit older. These are from 1990 to 2010. But the nice thing about this this link is that someone went through and organized all the topics together. So they put all the area volume together. They placed all the differential equations together. So if you want to just explore, if you want to feel like, oh, I want to get some extra practice with area volume, I want to see more of those problems, you can click on this link and it'll take you to Where's that link? Did I close it? Okay, I click on this again. So it'll take you to the free response notebook, and table contents organizes FRQs by topic. So area volume, if you want to do area volume, you can just scroll through the different area volume, read through those problems. So, just organized by year or organized by topics, just depending on which you feel will be helpful for what you want to do. So if you feel good about the FRQs and you want to explore multiple choice, I have a collection of multiple choice exams that were released by College Board for students to practice with. So they typically release these every 4 years, typically. But there's the most recent ones here, 2012, 2014. So 2014, I don't think is technically a released one, but I included a link. A teacher must have included it on their page. I found it, and I just referenced that link so you guys can have access to it. So yeah, that'll be good if you can if you want to just look through or work through the more recent multiple choice tests. But I have the links at the very top of the page. So if you go to the very top of the page, you're going to see the collection of the multiple choice tests along with full solutions. Now the 2012, 2014, 2012, I'm still working on the solutions. I will post that up later this afternoon. The 2014 one, I just had time to work through the more challenging ones, so I'll post that up. But if you have problems, ones that you're stuck on, you can feel free to just send me a text remind, and I'll work through it, and I'll send that solution back to you. Okay. All right, so so that covers for response and multiple choice if you want to get some additional problems to look at. Next up, I have the exam details and tips advice sheet. This is the advice and exam tips that I went through on Friday. It's under Friday's link. So you can go to Friday to watch the video for that, or if you want to just read through it. I encourage you guys to read through it. And then next, just calculate a reference sheet for your TI-84, whether you need just to remind yourself of different keystrokes or review through different keystrokes. And then finally, the lowest on the priority list is this miscellaneous and secondary AP exam topics. So there are some topics that I just kind of briefly went through in class, but I didn't really spend a whole lot of time on. I just had to kind of prioritize what I want us to do. So some of these miscellaneous topics, secondary topics, they've shown up on previous AP exams, but they may not necessarily show up this year. So, just every other year they may show up, but it's a lot of miscellaneous topics here. So if you have time, you can work through it. I have the key attached as well, but only if you have time, right? I don't want this to be the first thing and the only thing you do tonight. Only if you feel comfortable with FRQs and multiple choice and you're just looking for some, if you feel good about the major topics, then you can spend time looking through those secondary topics. I have the key attached, but if you have any questions, I don't think I'll be able to create a video in time, but if you have any questions, you can always stop by in the help session, and I'll go through it in detail with you if you like. Okay, so help session. I'm gonna have a help session this afternoon from 4 to 6 p.m. I want to finish working the rest of the FRQs from 2019, so probably numbers 3 through 6. And then with the remaining time, if you guys have any questions from multiple choice or questions from previous FRQs that you discovered just by scrolling through, I'd be happy to go through that with you, or go through a video going through that problem. Also, if you have any questions, send me a text remind for any miscellaneous questions you may have. If you're stuck on a random problem, take a screenshot of it, send it to me, and I'll go through the explanation for that. And then I know some of you may not get to reviewing until later tonight, so I want to be available if you have any last minute questions. So I'll get onto Teams like late tonight, like around 9 o'clock. And if you want to come in just to ask questions or want me to go through a topic or a concept with you, I'll be available at that time. And I'll record all these sessions so that if you're working really late and you want to kind of see what we did, you can click on that link. Okay, any questions that you guys have right now? Okay. I think, yeah, so on Friday, I talked about how when you go into that first portion of your AP exam, you're taking that non-calculator 30 multiple choice 60 minutes portion. You're gonna feel that time crunch. Okay, you're not gonna be able to go through every problem in the detail that you would like in the time that you would like. But just understand that, you know, don't get stressed about that. You know, everyone is under that same time constraint. And also, just because you don't feel good about every problem that you're able to get through, you know, just you don't have to get all 30 problems right to earn a good score. Okay, to earn a 5 on the AP exam, you're on pace to earning a 4 or 5 if you can get 15 to 20 correct. So if you feel good about 15 to 20 of your multiple choice, you're on pace to still earn a 4 or 5 on the AP exam, and even less if you want to earn a 3. So you know, you can just try to get through as much as you can. If you can feel good about 20, then anything that you get after that is just bonus, right? Bonus that you can help to balance out lower scores in other sections. So you'll feel the time crunch there. Just be really aware of time there. But after that, you're going to feel the time is going to feel more relaxed after that. But that first hour, you're going to be pushing. You're going to be trying to get through as much as you can. And you want to just spend your time as efficiently, as smart as possible. And then just, yeah, just try to get as many correct as you can. But just understand you may feel like you don't have enough time. So, but everyone's going to feel that, so it's okay. Okay. Any questions before we look at our FRQs? All right, let's look at number 1 and 2. Okay, so number 1, fish enters a lake at a rate modeled by E of t. Fish leaves a lake at a rate modeled by L of t. Both E of t and L of t are measured in fish per hour. And t is measured in hours since midnight at t equals 0. So these anti-derivative word problems, a lot of times they give you equations that are in terms of a rate. So we know there's going to be integrals coming up here. All right, so these are all in terms of fish per hour. So we know that for part A, it says how many fish enter the lake over the 5-hour period. If we just enter 5 into E of t, that's not good enough, right? Then what we're getting in return is the rate at which fish is coming in at the 5th hour. But we want to accumulate the number of fish over that period of time. We're going to have to change that unit of measure. We're going to involve taking the integral. Okay, so we go to our calculator. We'll enter in E of t under y1. So 20 plus 15 sine of pi x over 6. I'm going to exit out of the main, go to the main screen, math 9, f an integral from 0 to 5. Call my E of t. So I think it's really good to have that y1 and just keep calling that y1 that you need, because otherwise you're having to enter in all these functions over and over again. You can save a lot of keystrokes by just referencing these under y1 and y2. Okay, so if we accumulate the fish per hour over the 5-hour period, we get 153 fish. And notice our units changed, right? It started off as fish per hour. We accumulated that rate. The rate's going to disappear, and we're going to rise up to losing that rate from fish per hour to just total number of fish. Okay, part B. What is the average number of fish that leaves the lake per hour over the 5-hour period? So we're looking for average. We're looking for average rate. And if I think about average rate, I think about average value theorem. So we're going to apply average value theorem for part B. Hey, replace A and B with 0 and 5. I have L of t stored under y2. And I'm taking that integral, I'm going to divide it by 5. So under y2, I have my L of t. I'm taking the integral first. I don't want to forget about that 1/5. Oh, I keep doing this. I know this is something that I struggle with as well, is on the FRQs, just try to avoid equal sign if possible. It doesn't mean that if you do equal sign, you're going to be taking points off. It's just that there's just more peace of mind, right? Because every equal sign that you put on the paper, these graders are going to look at it very carefully. They're going to look to see, is that equal sign exactly what you mean it to be? Or are you just progressing through the problem? If you're progressing through the problem, you may not have them equivalent on both sides of the equation. So if you use arrows, you can avoid them taking points off for equal sign because there's a linkage error. So okay, so that gives me 6.059. Okay, leaving the lake. That's the average rate over that 5-hour period. Okay, any questions with A or B? Okay, I also want to kind of talk to you about the patterns of these FRQs that you're going to see. They tend to kind of ease you into the problem. So parts A and B tend to be a little bit easier, a little bit more straightforward. And then parts C and D tend to be more involved, more robust, just potentially trickier as well. So just be aware of that that flow that they're going to be doing, right? That A and B is going to be a little more straightforward, and C and D is typically going to be a little bit more, either more involved or more complex, or just basically more difficult in general. Okay. Okay, for part C, at what time t between 0 and 8 is the greatest number of fish in the lake? So I see the word greatest, I'm thinking EVT, I'm thinking absolute max. Okay. So we have to apply extreme value theorem. We have to find critical points. We have to find endpoints. We have to test them. But before we start all that, I want an equation that will tell me the number of fish at any moment in time. So with these anti-dirty problems, there's a formula that shows up a lot. And it's the idea that if I want to find a total amount at any moment in time, there's 3 components. There's the initial, there's the amount added, and there's the amount removed. Taking all 3 things into account, we can figure out the total amount of a value at a specific moment in time. So let me write that formula down, and we can adapt it for our problem. Okay, total amount equals initial plus amount added minus amount removed. They love to have these types of concepts on antiderivative word problems. So if I had to bet, you're going to see this play out in one of your number 1 or 2, if I had to guess. Okay, so total amounts. Now I'm going to build a formula, and this formula is going to be good because this formula is going to help us have a place to look for, to test all of our endpoints, critical points. But it's also a place for us to find our critical point. I'm going to show you how we're going to do that. So, so if I want to find the total amount of fish, total number of fish in the lake at any moment in time, my initial amount plus the amount added, which is the accumulation of my rate. But I'm going to leave my variable flexible to allow this to adapt to any moment in time. And then notation-wise, we just typically use a different variable so that when t gets inserted, it'll become e of t. So this will give us the accumulation of the rate of fish coming into the lake, and then the integral from 0 to t of L of x will give us the total number of fish leaving in a specific time period. Okay, so let me write off to the side here what we're trying to achieve here. Extreme value theorem. We're going to have to test endpoints and critical points. And the way we find critical points is we set the derivative equal to 0. So that's nice to know that we're looking for the derivative. And the nice thing also is we have the equation. So from the equation, we can build the derivative. From the derivative, we can set it equal to 0, and then we can make the calculator find that critical point for us. Okay, so let's find a prime, because a prime will be our derivative that we're going to set equal to 0. So every term, I'm just going to make it go through a derivative process. A becomes a prime. A of 0 is a constant, so let's just go to 0. The derivative of this term is going to wipe out the integral, so I'm just left with e of t, right? Derivative of integral, that second theorem, we know that's going to wipe out those two operations, which just undo each other. And then the derivative of integral L of x is just going to wipe out the integral here. I'm just left with L of t. So there's my derivative. I'm just going to set my derivative equal to 0. So this is how we're going to use our calculator. We're going to graph this. And we're just going to look for the x-intercept. Okay, so this is where a calculator is going to come in handy. So E of t minus L of t, I'm going to go to my calculator. Rather than entering in E of t and L of t all over again, I'm just going to reference them and say y1 minus y2 under another line. And that way I can reference this without having to graph everything. And I'm just going to highlight my y3 because I only want to see y1 minus y2. I don't really want to see the other graphs all overlapping each other. Okay, graph. Okay. I'm looking for my x-intercept. I see an x-intercept between 0 and 8. I want to make a note of that. That's going to be a critical point that we can use to test. So let's do second trace, 0. I'll pick a point to the left of the x-intercept. hit enter. Pick a point on the other side of the x-intercept, hit enter. Find R0, which is x equals 6.203. And then we also want to include our endpoints as well. So ultimately, we're going to be testing these 3 points or these 3 values against our A of t, right? We have our candidates, and we're going to test them against A of t to see at what time period will there be the most number of fish. So A of 0 is easy. There's no fish in the lake. Let's do A of 6.203. A of 8, we can also test. Okay, rest can go in our calculator here. We know A of 0 is just 0, so we can just remove that. Sorry, 6.203. By 2, sorry. $135 fish at 6 hours in. Okay, so now we can test how many fish at the 8th hour. So I'm just going to go back to my previous entry and just update my upper bound to 8. Okay, so we have our 3 candidates, right? Either 0, 135, or 80.9. We're looking for the most, where there's the greatest number of fish. So I initially just wrote down 135 fish, but then reread the problem and I realized, oh, this is not asking for the number of fish; it's asking for the time. So I think it's a good habit for you guys to do is, even though you know what your answer is and you have the answer in front of you, go back and read the problem. Make sure that you're answering or that you're providing what they're asking for. So if we go back to our problem here, it says, at what time is the greatest number of fish in the lake? So the answer is not going to be 135. The answer is going to be 6 hours. At what time? Okay, any questions A through C? Okay, let's look at part D. So part D, it says, is the rate of change in the number of fish in the lake increasing or decreasing? So I'm going to focus on my attention here on the first part of this problem here. Is the rate of change of number of fish in the lake? So the rate of change in the number of lake is going to be based off A prime of t, right? We know A of t represents the number of fish in the lake. A prime is going to represent the rate of change in the lake. So we know A prime is E of t minus L of t. That's what this is referencing. So I'm going to write that formula there. That's this A prime represents the rate of change in number of fish in the lake. But this is part D, so we know it's not going to be quite as straightforward as we would like. It says, is rate of change in number of fish increasing or decreasing at 5 a.m.? So can we just plug 5 into A prime and arrive at what they're asking for? That's right. Yeah, it's going to be involving A double prime. It's very subtle, right? Because if they were asking for A prime of 5, then they would just say, is the rate of change in the number of fish positive or negative? Right. But here they use the word increase, decrease, which is a subtle way of saying, tell me the derivative of this value that we just described. So yeah, anytime you see increase or decrease, you got to circle those words and see, okay, they're trying to trick me, not trying to trick me, they're trying to see if you can understand that there's a derivative, a process going on with this expression. So increase, decrease is asking about the rate of change of this expression, so we need A double prime. So if I want to find A double prime, I got to involve these derivatives. So I'm going to make everything go down one derivative level. So E becomes E prime, and L becomes L prime. And now I can insert 5 in here. Okay, so we want to know what the value of A double prime of 5 is. We can go to our calculator. I have E of t and L of t stored under y1 and y2. I can just go to nderiv math 8 to make it evaluate the derivative at 5. Oops, 5. Negative 6.801. Sorry. Evaluate the derivative for L of t, which is stored under y2. Combine those values together. A double prime of 5 is going to be equal to negative 10.7. And the units is going to be fish per hour, so fish per hour squared. It's asking for justification, your reasoning. So we're going to say the rate of change in number of fish in the lake is, okay, they want us to use increase or decrease. So we're going to target decrease because we see a negative. Okay, any questions there?
Say because it's less than 0 or something.
Oh, say because what?
Because it's less than 0.
You can. I think the negative already indicates that it's decreasing, so it wouldn't be wrong if you said less than 0 though. Okay. Any other questions with number 1? Okay, let's look at number 2. So this is merging of particle motion and Riemann sums. A lot of times problems on the FRQs merge these two topics together. Okay, so number 2, velocity of a particle, p, moves along the x-axis given by a differentiable function, so smooth curve, where v of p of t is measured in meters per hour and t is measured in hours. Select values of v of t are shown. Particle p is at the origin at t equals 0. Part A, justify why there must be at least one time t in the interval from 0.3 to 2.8 at which v prime of t, the acceleration of the particle, is equal to 0. So we basically are trying to, we're given v of t, they're asking, is there a place where v prime of t is equal to 0? Can we guarantee a place where v prime is equal to 0? So hopefully, just by the way that they're referencing this, we can see that this is really them trying to see if students can connect this with Rolle's theorem. Okay, and Rolle's theorem says if a function is continuous, if a function is differentiable, if the endpoints are the same y value, then there must be a place where the slope is 0. So as a visual reminder here, if I were to connect all these order pairs at 0.3, velocity is at 55, it's going to drop down to a negative value, but it's going to have to come back up. And if it comes back up, back to 55, we may not know exactly how low it goes, but we do know that however low it goes, it's going to come back up. And in that process, it's going to have to reach a slope 0. And thereby guaranteeing that Rolle's theorem is achieved. There's a guarantee of slope 0 where acceleration is equal to 0 somewhere between my two endpoints. Okay, any questions with part A? Okay, part B, use trapezoid approximation to evaluate the integral from 0 to 2.8 of v of t dt. So trapezoid approximation make sure we memorize this formula. You can almost guarantee that there's going to be some trapezoid approximation showing up somewhere on the test, either multiple choice or free response. But it's 1/2 width, height 1 plus height 2. Okay, so I'm going to go to my table, create my intervals, find my width, identify my heights, subtract the t values to get the width. Oh, sorry, I started at 0. I should have started. Oh, sorry, no, we don't have to go past 2.8. Okay. Okay, so those are my width values. Okay, all that's gonna, the rest can go into our calculator. So this is a calculator section. So calculator section, you can enter all this in the calculator and get that value easily. That's what I would suggest us to do, even though you could get away with leaving it unsimplified. But I think the reason that you want to just go ahead and do that on the calculator section is because you may use this value later. They may reference this later, and you may need that value anyways. But if it's non-calculator, then I would encourage you to just stop at this point. There's no need to do all those calculations. Leave your answer in that one big mess, and you'll get full credit. So don't try to go any further than that. But if it's calculator, then spend the time to get it down to a number. Okay, any questions, A or B? Okay, part C. So we can kind of expect the difficulty to kind of ramp up a little bit here. So part C, a second particle, Q, moves along the x-axis so that its velocity between 0 and 4 is given by VQ of t in meters per hour. Find the time interval in which the velocity is at least 60 meters per hour. So I'm going to figure out when velocity is at least 60 meters per hour. Let's create an equation or an inequality that represents that. So I want to know when my velocity is at least, so in my mind, I'm thinking that's greater than or equal to 60. Okay, when is the velocity is going to be at least 60 meters per hour? Okay, so I want to find my critical point. I want to get it to a form where I can enter in the calculator and quickly get to my value. So I'm going to bring that 60 over, subtract it. And now I'm going to have an easier time to just use my calculator here because I just want to use this. I'm going to graph this. And I'm just going to look for the x-intercept. So go to my calculator. I'm going to enter V of Q of t under Y4. You can erase the previous and do earlier Y1 or Y2, Y3 if you like. It's just, I'm going to use Y4. So V of Q of t is 45 root x cosine of 0.063 x squared. I'm also going to subtract 60. That way I can just graph this and look for the x-intercept. Oops, I should have removed my previous graph here. I'm going to unhighlight 3, so that I'm only seeing this last one that I care about. So we have our critical points here. And we want to know, when is the graph going to be above 0? So it looks like we're looking at this interval here. We're going to be able to find the total distance using this information here. So I'm going to find these critical points by going to second trace 0. T equals 1.866. Second trace to get to that second one here. .519. So we know that there's a formula for distance. It's the depth integral from x1 to x2, absolute value of v of t dt. So we'll just apply that formula there. Oops. 1.866 is down here. Absolute value of my velocity. Make sure if you're when you put your absolute value notation, that you put it in the interval here, that you don't put it outside the integral notation. You put it just within the expression between the integral notation and dt. Careful though that right now, if you're using y4, if you did the same way I did, you got to remove that 60. Because I just want to find the integral of my velocity function. So math 9. To get to absolute value, you're going to go to math, number, ABS. And I have y4 holding my velocity function, dx. Total distance in that time interval where the velocity is at least 60 meters per hour is 106 meters. Okay, last one here, part D. At time t equals 0, particle Q starts off at -90. Using results from part B, approximate the distance between particles P and Q at time t equals 2.8. This is kind of like a two-part problem here. We got to figure out the location of particle P. We'll find out the location of particle Q, and then we'll compare their locations. So anytime I'm looking for a final position of a function, I got to rely on this formula, right? Final position is equal to initial plus displacement. Okay, so I'll focus my attention on particle Q to begin with. So particle Q, we have initial time. So I'll say x q of 2.8. Initial is x of 0, plus however much progress this particle makes between 0 and 2.8. So we know that particle Q starts off at negative 90 on the x-axis, but then the rest we can go into our calculator and evaluate. Again, I have it under y4. $135. Oh, sorry, positive 45. Okay, so we know that particle Q ends up at 45.93 on the x-axis. Let's figure out where particle Q, or sorry, particle P is. Initial position plus displacement. But here, particle P starts off at the origin, which is 0. And then we'll just use what we got from part B, right? It says use the approximation, use the result from part B. So that 40.75 is going to come in handy here. So particle Q ends up at 45.9 on the x-axis. Particle P ends up at 40.75 on the x-axis. So the problem just says, what is the distance between the two particles? So if we just subtract those two values, we have the distance. Okay, any questions? Okay, so we only got through 1 and 2, but I think these are good time well spent on problems and concepts that you're likely to see tomorrow. Okay, so this afternoon I'll have a health session. I'll go through the rest of these problems. I'll record the sessions as well. I'll send out a reminder about sessions for tonight, this evening. I'll send out some final reminders through text, just things to remember, things to last minute things to do, things to bring tomorrow. But hope you guys do well tomorrow. Yeah, best of luck. Hopefully I'll see you this afternoon or evening. If not, I'll see you guys Wednesday. Okay, thanks everyone. Have a good day.